Our next presenter is Mike Bannister, and he will start out the session on interventions in watersheds. This gets down into more specific kinds, some of the things he is talking about, and gets down into some more specific kinds of activities and lessons learned. Some of the questions that were raised earlier this morning, Mike can speak to some of those by simply giving his presentation. And of course, we're very interested in your comments and reactions afterwards. So let us proceed with Mike Bannister in looking at NRM practices and limitations.
Okay, thanks, Glenn. Yeah, I'm talking about natural resource management practices with a bias, and my bias is this. I was a field technician for 16 years in Haiti working on projects, so I'll have a project bias. I also realize that you can't solve entire watersheds problems by doing just a project approach, and that governance is very important, and economic development and policy is very important. My bias happens to be projects, and AID does projects, so you may notice that as we go along. Briefly, in Haiti, for those of us that don't know, quick description, it's mainly mountainous, 60% rural, and the farms are very small and they're very complex. A farmer may have 3 or 4 plots totaling less than 2 hectares in total area and held under different modes of access. They may own some, about 75%. They may rent some, and they could be located in different ecological areas as a strategy to ensure yields over the year. They're market-directed, not subsistence-directed. Almost everything's for sale, and agriculture is not the only domain of economic activity. Farmers worry about other things. Probably 50% or less of their annual revenue comes from farming activities, and they also have other activities, small business activities. Well, let's start with something apparently startling. I don't believe that the future of Haiti is intensive hillside agriculture. In other words, I don't think that national watershed protection problems can be solved because every plot on the hillside practices correct soil and water conservation practices and does annual cropping. And I think that for the reasons that you see listed here. Mainly, it's really expensive to do that on a degraded resource base. There have been a couple of estimates made. The government of Haiti estimates that it would cost $500 to $700 per hectare to treat watersheds. And if you calculate it another way by looking at a current IDB budget and the number of hectares they propose to treat, you'll get about $1,400 a hectare. So if you applied that level of intensity over all the hills of Haiti, you'd end up with a bill of $2.7 billion. Okay, now, this is not to say that you shouldn't do projects. In fact, you should do projects. We've learned a lot of lessons about projects, and a lot of things have worked. It's worthwhile to do them because they can speed up landscape restoration and restore ecosystem functions, mitigate poverty, and slow anarchic growth in cities, which would give you time then to build up economic engines in secondary cities and work on universal education. And then not all watershed problems can be addressed in the same way. You need market projects, market activities, but they can't do everything. We also noticed that animals and tree crops are the most important on-farm revenue sources here. This leads us to looking at a combination of approaches to address watershed problems. And here are some of the models we looked at to draw lessons for a combination approach. I won't go over all of these, but there's some of them you may not be familiar with. This one, Équipement de Territoire, that's an old model that we reject completely. Basically, it's paying farmers to build linear soil conservation structures across vast swaths of territory because you pay them salaries per day. And you don't see traces of those. So we reject that one. We accept the jobs creation civic infrastructure that could be a stepchild of the first one, though, because those have now evolved to the point where they're considering the socioeconomic structure of Haitian farm families. There are a couple of interesting points left here. The new mutual interest coalitions. I'm pointing at the wrong thing. You didn't see that? What? We visited with 4 groups of elite commercial class people that are recognizing that the only way they can make a profit is to do social interventions with farmers to protect their own infrastructure. We visited, for instance, with Gregory Meves, who's reportedly the richest person in Haiti. And he has a plot of land down in the cul-de-sac where he is collaborating with farmers to raise plantains, actually bananas, Cavendish bananas, and he's getting organic certification for them. And he's making a profit, and they're getting access to land, and he's pumping back a percentage of the profits into social activities with them. And we saw 3 or 4 other different cases. The mixed models and convergence of ideas. Projects now are taking lessons learned from all of these models and combining them. And we'll look at that specifically as we go along here. What we do draw as a lesson is that there has never been a project that has covered entire watersheds in Haiti. So we don't have a precedent to work with. The projects that have worked, a lot of them had a long-term relationship with the farmers and have stayed in the area. And what we're seeing now is that recent projects that are being designed are drawing lessons from all of these different approaches and proposing to do plot-based interventions along with civic infrastructure repair by paying people, along with marketing, along with tree grafting, along with fruit tree production, all in combination over a long period of time. So all the watershed problems can't be addressed in the same way. They need to be addressed in combination over a long period. Now I'm just going to go through the types of soil conservation structures and natural resource practices that can be done in watersheds. Linear structures to protect the sides of the mountains. They can be in several different ways. They go across the contour. They're supposed to stop water and stop soil, stabilize the slope, according to the technicians. To the farmer, they're supposed to make money. If you build them with trees, they're called hedgerows. This one is a hedgerow. This one is a hedgerow. There you go. And it's across the contour, and it's made with a single row of a leguminous tree that's managed by cutting it off about knee-high so that it resprouts. It's managed as a bush. If you do it with rocks, it's called rock walls. And if you do it, a descendant of the hedgerow is called a bann manje. If you do it instead with perennial food crops, like sugarcane and pineapple and bananas, that would be called a bann manje. It means a band of food in Creole. And then the Tram is interesting. It's a linear ditch across the contour. This is the only case that I know about where an indigenous system of soil conservation has evolved without a project intervention. Up above Port-au-Prince in the Fiercy-Kenskoff area, farmers do this, and they have to do it every year, rebuild it. You dig a ditch, the soil erodes down into the ditch. After the end of the season, you throw it back up on the hillside. This arose after chemical fertilizer was used to grow vegetable crops for the big market in Port-au-Prince, which is very close and connected by a good road in the 1950s and 60s, promoted by Haitian agronomists. Farmers don't do that to conserve soil or water. They do it to conserve fertilizer. This is a fertilizer conservation structure. I'll use these contour structures as an example of how economics drives technology evolution. There are several examples there. I'll just look at one of them. Here in the bottom there, that is a hedgerow, but it's made not out of the original tree we proposed in the mid-'80s, but it's made out of perennial cotton. And that's done in response to a market for cotton wicks that go in kerosene lamps that are used in a very large voodoo ceremony that happens once a year that attracts about 100,000 diaspora to Sodo. And they've evolved in other ways. So farmers aren't seeing these as soil conservation structures. They're seeing them as money-making ventures. In ravines, there's 2 scales of ravine interventions. One that farmers can do on their own plots, and one that they can't, which is in large ravines where there's a lot of erosion that's completely beyond the capacity of individual farmers to address. But the ones that are on their own plots pay off fairly quickly, because what happens is if you put rocks, well, that's pretty dark. If you put rocks or vegetative material or even bags of soil to block the erosion, very quickly you accumulate soil on the uphill side. And that's a new irrigated garden plot because the ravine is where the water accumulates. So now you have an irrigated small garden that you can plant plantains and taro and other high-value crops, which is what they do. Okay, then we have hardwood tree planting. Here we see a nursery producing hardwood trees operated by an NGO. And the hardwood trees are distributed to farmers free in boxes, and that small container technology solves the transportation problem. Hardwood trees tend to be planted in larger numbers than fruit trees and further from the house. So you can carry in a small cardboard box about 150 to 200 trees if they're grown that way. Fruit trees, however, are grown in larger containers. In seedling, they're grafted in the nursery or they're grown from seeds in the nursery. This one is mango over here and aki over here. And then they're harvested and then they're marketed. They're very much oriented. They're popular because they're connected to marketing programs that have succeeded in Haiti. But you can't take those seedlings very far because they weigh a lot, maybe about 10 pounds after you water them. Another way of producing fruit trees is to replace the crown of a low-value mango that probably will be harvested to feed the dry cleaning industry because the mango tastes bad and has a lot of string in it. But if you cut off the branches, wait till they resprout and graft onto them, what these little white flags represent. This is a rather over-enthusiastic example, by the way. Should only be 3 or 4 there, but in any case, what you end up with is a manufacturing plant that produces high-quality export mangoes that can be sold at a good price. Water. I don't have direct experience with the water interventions, but one of the watershed level AID projects has had that experience. The Asset Project found it was very useful to leverage soil conservation and vegetable production with credit to build on-farm cisterns. And that's important in Haiti because you have maybe over the year an absolute adequate amount of rainfall, but you can't trap it and you can't use it. So you end up with a pseudo-drought. It runs off and it comes at a very strange time every year. You may not conform to the needs of the plants. Okay, let's look at these technologies in a very brief, different way. This table, red is bad, green is good. Okay. So what you have here on up are linear soil conservation structures, and here on down, gully plugs and trees. The red means the cost of installation is high, cost of management is high. Maybe you have to wait a long time for the benefits to come, and then maybe a high risk. And the green means the opposite. So if you go out in the field, you'll mainly see gully plugs, trees, and grafted fruit trees as interventions carried on by farmers, and not so much these others. Okay, technologies. I'm not going to read these because I'm going to illustrate them with a series of case studies that follow, 3 case studies that we gathered from recent visits. But the point I want to make here through these case studies illustrate that we have found examples where projects can change landscapes, and that projects can increase household income, and that projects can influence for the better agricultural practices. So let's look at these points as illustrated by 3 case studies. The first one is Fond de Blanc. Value added is the important thing here, but what's happened here is actually there's been a radical change in the landscape since 1981 when tree distribution, or 1982 when tree distribution started in this area. There's just a large amount of landscape covered in trees now, and it's a really radical change. Almost all of the charcoal that comes out of this area is coming from project trees and wood products too. The organization working here is called CODEF. They've been there for 24 years. They work on several aspects of concern to farmers, including animals and roads and water. But they do this. They have 3,000 members. Every one of them have woodlots of between 250 to 500 trees each. The amount of charcoal coming out there has multiplied many, many times. And they've gone farther. Now they have, can you see that well? here's the production, and here's what's the result of the production and the distribution. They've harvested the wood, and they have purchased a sawmill, and they have purchased woodworking tools so that they can saw the wood and they can make furniture. This is an example of a value-added activity that's working very well. Okay, that's one. Here's another one. If you go to Cape Haitian and then you hang a right and you go towards the Dominican Republic and you get to Terrier Rouge, so we're in the northeast part of Haiti, and you go from Terrier Rouge to Perche to Acul Samedi, you'll start to see more and more and more project trees. I don't know how far it goes. It would be interesting to look at that, and I'll recommend that in a second here. But here also there's been a radical change in the landscape, and from talking to the folks up there, there's a big change in the amount of charcoal being produced. Almost all the wood products are coming out of that come out of the area are from project trees. And an interesting change in the agricultural practices has happened. You see this plot over here, and I know it's hard to distinguish, but what's happened is that this tree here, Acacia auriculiformis, it doesn't coppice very well as some of the others do, like eucalyptus here. You plant it once, you harvest it 4 or 5 times or more. But these don't coppice as well, but they are a very prolific seeder. You'd think that when they seed heavily into a farmer's plot, the farmer would be really ticked off. But just the opposite has happened here. The farmers actually consider it a treasure in their field. They've changed their crop management practices to integrate it. So this is thickly populated by 50 centimeter high acacia seedlings. And it's intercropped with cassava and sometimes beans and maize and sorghum. So what they'll do is annual cropping until the shade gets too much. Then they'll leave it as a pole garden, and then this will be the result. They'll harvest poles and get a good price. Okay, so the last example is how a small contiguous area, in this case about 9 hectares, can be transformed due to soil conservation activities supported by a project. Well, in this case, this is an area just outside Cape Haitian, and here's Wangari Maathai visiting us there with Lionel. Where's Lionel? Raise your hand. There's Lionel with hair. There's me with hair too.
I mean with her.
Yeah. Anyway, so what happened was that the team leader, who was supposed to have been with us today for the PADF Plus project in this area, decided to do a demonstration of what's the maximum capacity you could achieve with soil conservation technology. So this area actually received a lot more project inputs than normal. In other words, it did training on here, and in the guise of training, a lot of labor was contributed to the plot, and a lot of germplasm was contributed. But there's 15 farmers and 9 hectares, and this is the amount of money that we estimate roughly that was invested, $665 per hectare over 5 years. And the results came in 2 stages. When Wangari Maathai visited in '95, the farmer told us that his management cost for the plot had doubled, but his income had quadrupled. And there were some linear soil conservation structures. But we just visited again a month or 2 ago. We found that there's no linear conservation structures left, no hedgerows. It's all trees. And 80% of his $220 per hectare that he made last year over his 5-hectare plot, 80% of it came from tree products. Okay, so the question is then, do we really have to spend that much to get that effect? So maybe we wouldn't have had to spend that much to get that effect. Okay, recommendations quickly. I'm going to slice and dice the recommendations in several different ways. These first 2 are about the general model. Essentially, first I'm just recommending that a few very short-term, easy-to-do studies be made to confirm the findings that I just showed you in those 3 case studies. It wouldn't take long, and it wouldn't impede the implementation of any projects. It wouldn't take a very large team to do them, but it'd be nice to confirm what we just found. Because how far back does that tree coverage really go? Has the charcoal production tripled, quadrupled? What? How much money, has the percentage of income, farm family income, doubled because of this, or has it had relatively little effect? It'd be nice to understand that, and also do a charcoal consumption study in Port-au-Prince to key into that. Okay, recommendations for the model that we would propose AID do. It would be a mixed model. By that I mean do the traditional soil conservation and tree distribution activities that farm households have done, but also do the jobs creation type approach in large ravines and repair of irrigation systems and that sort of thing. And do marketing and have the participation of stakeholders that understand that there's a plan for the whole watershed and they understand what their participation in that plan is. And include other projects and the private sector and the Ministry of Agriculture, Government of Haiti, especially for things that require a long-term approach, like research on varieties. And that's something that's needed very much in the tree area and in the jatropha area too, we'll see pretty soon. Okay, overall though, the idea is to encourage a shift from annual cropping to perennial cropping on hillsides. It's not going to be possible everywhere, but it'll be, what we do is when we accept that this is a watershed intervention, once having selected the watershed, then we have to stay there over a long period of time. Do I dare say this, or should we just read it? 20-year commitment in watersheds. That's probably because you choose the watershed, then you say, okay, these traditional interventions didn't work in this plot. Well, what will? So then be flexible enough to, and long-term committed enough to stay there until those things can be worked out. Okay. You can also look at dry areas versus humid areas, what works and what doesn't work in each one. The main differences here that I could figure out anyway, jatropha is very good for dry areas because it's not very demanding of the site. You could, does everybody know, I wasn't here this morning, jatropha, is that a strange word?
Yeah,
it is, okay. Yeah, this is the plant that, it's biodiesel plant. But it's not very demanding at all. You could plant that over large areas of dry. And goats, make sense to work with goats in the dry areas because they're a really good environmental buffer. In other words, they filter out the ups and downs of the plant by turning those into an animal. And goats have saved a lot of Haitian farmers. And whereas in the humid areas, maybe these linear soil conservation structures would make more sense. Okay, hardwood trees. We're supporting the large-scale distribution of hardwood trees. There's a huge demand for them at zero cost. For energy, we're saying use the charcoal market, don't discourage it. Work on the efficiency of the kilns and the stoves that burn them. There is a lot to be said, though, for the traditional system of just piling up the wood and putting vegetative material and soil over it. It's not very efficient, but it doesn't cost anything either. And you don't have to carry your wood to a machine. It's right there. But there have been some lessons learned in other projects that you can convert charcoal more efficiently. But what we especially need is for AID to push for policy changes to make managed tree harvest legal. Farmers should understand nationally that they can now cut trees legally and make charcoal with them. Marketing. All interventions should be linked to the market. Especially interesting is cross-border trade with the Dominican Republic because a lot of the things the Dominican Republic is interested in come from trees. Perennial crops and trees are of interest, and so are animals. Also might work on organic certification and, I don't know, it's a shot. Try branding charcoal for the elite in Port-au-Prince. If we could connect a brand stamp on the bag of charcoal such that they understood that came from a well-managed and sustainable plot in the countryside, I think there'd probably be a lot of elite class people in Port-au-Prince interested in that. I don't know how far it would go. You'd have to look before you leap on that one. Okay, animals. We're supporting animals. Don't kick goats because they save a lot of people. But one way of promoting animals is to link with projects that already do that work, because I think AID's been burned in the past by participating in animal projects that led into this entire veterinary medicine approach. But there are projects like VeteraMed that take you from production to marketing. So they could be invited in where possible. And then link the animals to trees and marketing through forage improvement. Okay, well, just to sum up then, scaling up could be attained by a combination approach: trees, ravine stabilization, civic works, investment in soil conservation animals, new approaches to be developed with the community, but over the long term with a heavy influence of marketing, collaborating with the government of Haiti, especially the regional Ministry of Agricultural offices, but also private universities in Haiti that are really interested in doing research on this, and the private business sector. Okay, thanks.
Thank you, Mike. As part of this session, Mark Portnoff will talk about another more specific option, specific sector of biofuels. Our team responded to this concern because there was such interest in trying to understand it, a lot of interest in Haiti amongst both public and private stakeholders, private sector people, small farmers, and government spokesmen. So Mark will address this issue.
Good afternoon. It's a pleasure to speak with you, and I too have been very honored to be working with such a fine team here. The outline of my talk is I'll summarize the purpose and strategy of my part of this assessment. The selection of an energy crop. As we've heard, Haitians have a vast experience with biofuels, but more like solid biofuels, charcoal and bagasse. This talk is going to be focused on liquid biofuels. We'll look at market conditions, look at the selection process between ethanol, biodiesel, pure plant oil, talk about energy crop plant selection. I'm going to give an example of how one would take a tropical oil fuel and take it to the market, review some policy options, and then recommendations. So the purpose is to assess the potential of biofuel crops to promote increased planting of perennials on slopes in place of erosion-intensive food crops. And the strategy is to find a high-value fuel substitute that can provide a fair return to the local farmer and community, find a plant that can be grown in selected Haitian agrosystems, limited rainfall, marginal lands and slopes, and minimal agricultural input, and then when properly planted, are able to reduce soil erosion. You know, it's in the news, right? Biofuels are a growth industry, especially ethanol and biodiesel. And there are really two factors for biofuel market growth. One is biofuels are built on solid, strong, and modern agricultural sectors. And the other is public policy and tax support. Why do governments support biofuels with tax incentives? I mean, they believe that the investment is worth the benefits. Just a few biofuel benefits in general. You know, it's homegrown energy, so it promotes energy independence. It promotes rural economic and agricultural development. It's a renewable energy source. It's sort of solar energy a few months delayed. Burns cleaner and can be used with the existing petroleum infrastructure. Now, we're going to look at the selection of biodiesel over ethanol in the context of Haiti. Ethanol is used as a gasoline fuel substitute. Biodiesel is used as a diesel fuel substitute. And look at market considerations. Haiti uses twice as much diesel as gasoline, and diesel is used for both electricity production and transportation. Ethanol requires a bigger infrastructure, and so that's a barrier. You need facilities that are 3 to 10 times larger than those for biodiesel. Current price supports for sugar. Sugar in the Caribbean and South America is the source, the feedstock for making ethanol. And farmers in Haiti can make more selling sugar for consumption than they could for producing ethanol. And Haitian stakeholders raised the concern about growing food crops for fuel. But now we're going to look at the comparison of biodiesel versus pure plant oil. And what I'm going to do is run through a series of slides just talking about how you take and create pure plant oil or biodiesel. And you start with vegetable or plant seeds. And you take them through an oil extraction and refining process. This process is well established either at the personal level with manual presses, the village level with a small industrial system, or the industrial modern agro systems. So you get two products out of this oil extraction and refining process. You get seed cake, which, depending on the type of plant or vegetable you're using, can make a very fine animal feed or fertilizer. And then the other product is plant oil. And for the economics to work, each product has to have some sort of market value. Now, if you want to take the plant oil and make biodiesel, you got to go through what's called the transesterification process. And that process requires equipment, facilities, requires alcohol, chemicals, power, and water. And depending on the economies of scale, that's going to add cost to the finished product. So if your plant oil costs $2 a gallon, you could be looking at $3 or more a gallon for your biodiesel. Now, why is biodiesel so exciting to people is that it's a certified transportation fuel. The United States, the EU, Japan, Brazil, they all invested a lot of money in certifying biodiesel. It burns clean, it's passed the Clean Air Act, it's overcome a lot of commercial barriers. Engine manufacturers will let you use biodiesel without voiding their warranty, right? It can work in the existing petroleum infrastructure. But again, it requires added facilities and adds cost. What about pure plant oil? In Africa and across Asia, at the village level, people have been using pure plant oil fuel for making electricity, electric power generation, using indirect diesel engines, or you can modify direct injection engines. So pure plant oil is a finished product. So now this is a way to get the most value added to the local farmer. Because after he grows his crops and makes pure plant oil, he's now selling a product that's competing with diesel fuel without having to go through the extra production steps of biodiesel. Pure plant oil can also be used, besides electric power generation, for powering grinding mills, small seed pressing operations, irrigation of fields. It can also be used for cooking, soap making, and lighting. So in the context of this assessment, we're looking at plant oil fuels being recommended over biodiesel. First of all, Haiti doesn't have a solid, strong, modern agricultural sector upon which the biodiesel industry depends. The biodiesel production adds a whole layer of technology and facility infrastructure, so it makes it more complex to implement. And biodiesel producers will seek to depress the price of the plant oil. It's the buy low, sell high business strategy. And this is going to reduces the return to the local farmer unless they own the biodiesel production facilities. I'm going to switch up the talk here. We're going to talk about energy crop plant selection. And this is really not an area of my expertise. I've depended a lot on the agronomists on the team for this. But by and large, there are a lot of indigenous plants in Haiti that have seed oil crops that can be used for either plant oil fuel or biodiesel. But most of these plants are food-based crops, and many are not well suited to the growing targeted agro-system. Make it clear, there's no magic bullet here. There's no magic plants that are going to solve all of Haiti's problems. But there are several plants that meet a lot of the criteria that we look at. We're looking for an indigenous plant, a perennial, so it minimizes soil disturbance. We're looking for plants that require minimal agricultural inputs, adaptable over the rainfall and elevations associated with Haiti, grow on marginal lands and slopes. When planted correctly, minimize erosion and soil depletion, have high seed oil concentration, high seed cake value, potential for genetic improvement and agronomic inputs, and accommodate small-scale seed oil extraction equipment. Like I said, there are a lot of plants that meet most of these criteria. There are no plants that meet all of these criteria. But when I went and visited Haiti, there's great excitement about this plant, the Jatropha curcus. Okay, so this is not an idea from America coming to Haiti. This is Haitians coming to us saying, we're excited about this idea. I met a lot of Haitian citizens that say, we want to stay here, we want to make our country better, we want to promote the rural economic environment, we want to save our hills, our slopes, and they look at this plant as a plant that has that potential. And it meets many of the criteria that I just reviewed. One thing to point out is that Streptococcus is toxic. Now, that's a positive when you're trying to make a living fence that you don't want animals to eat. So you can grow these the goats don't eat Streptococcus. The Haitian farmer has a lot of experience with this plant as a living fence. They know how to handle it safely. But if you're going to start doing widespread agricultural development, there's probably the need for a risk assessment, for developing a body of scientific evidence to make sure that when this plant is used on the large scale for fuel, that we're not harming the ecosystem in some unexpected way. The other problem with this plant is that there's no markets for the seed cake. In Africa and Asia, where this plant is commercialized on a village level, farmers value the seed cake as a fertilizer, organic fertilizer. So it has value. And as I go through an example later on, you'll see that without value, the jatropha oil is not cost effective or not cost competitive against fossil fuel, diesel fuel. As I said, here's a picture of jatropha, the living fence on slopes. The Haitian farmers have a great deal of respect for this plant. It's used also for medicinal uses and cultural value. The private sector, as I said, in Haiti is very interested. This fellow here, Reginald Noel, I'm one of the fathers of biodiesel in Haiti. I mean, he's taken his own personal money and his own initiative to make biodiesel as a way to let me put it this way. This is an individual who could leave Haiti, but has chosen to stay. And he wants to do something to make his country better. And to him, biodiesel or pure plant oil fuel are things they can do. The enthusiasm is, this is something we can do to make our country better. And I found this at the ministerial level, environment, the Minister of Agriculture, the Minister of Energy. They're all very equally excited, as were private sector individuals interested in trying to improve the rural economic structure and to use biofuels because it's just good for the environment. I want to point out that in this slide's pretty complex, but what we're talking about, I'm talking about, there are a lot of steps from taking a seed to a finished plant oil or a processed seed cake product. And there are numerous technical details at every step. And what I'm trying to propose is that we come alongside all this enthusiasm for biodiesel and provide the technical support so that they don't hit barriers that they can overcome. We have the seed processing technology. How do we get it appropriately located at the village level so that the farmers make money, so that these opportunities, the enthusiasm that's there, is not diminished by setbacks? Now, there are a lot of ways to create a market for plant oil, and this is my favorite, right? I'm the author, I get to present that. But it's taking jatropha plant oil for electric power production. Now, there are a lot of local electric power utilities. I'm going to use EDH in Port-au-Prince as the example. And they use 3.5 million gallons of diesel to generate electricity for 8 hours a day. Now, if you took jatropha oil blend at 1%, that creates a market demand for 35,000 gallons a month, or 426,000 gallons a year. Now, why 1%? Because my understanding of EDH's equipment, they can blend 1% oil, jatropha oil, and they don't have to modify any of their equipment. So all of a sudden if there was a homegrown fuel they could use, it will actually burn cleaner, and it can use their existing equipment. And that's a huge market, actually, considering that the jatropha is not a product right now in Haiti. So you'd be looking at 1 year's production of jatropha oil. We're requiring more than 4,000 miles of living fence, at using data collected in Africa on marginal lands. So, right now, if EDH agreed to blend jatropha oil, there's a market developed. And the Haitian farmers are very industrious, and they would look to find a way to meet that market. EDH currently purchases petroleum diesel in bulk at about $2.30 a gallon. So that would sort of be without price supports, that's sort of the selling price that the oil is going to have to meet. Now, this next series of slides is, is talking about just one segment of the multiple segments it takes to make pure plant oil. So we're just looking at the seed price. This is the beginning of your value chain. So if you took a manual press, you would need like almost 42 pounds of seeds. You're pressing these seeds, and you get 1 gallon of plant oil. Using data from Africa, and I'm extrapolating it to Haiti, you need to, those seeds have to sell for at least 6 cents a pound if a Haitian farmer is going to meet the official minimum daily rate. And so that means the dried seed costs are $2.50 a gallon. And that's more than what, that's just getting your seeds. That's not pressing your seeds and refining the oil and transporting the oil. So clearly you're priced out of the market with a manual press. So there's a need to maximize oil extraction. So let's say we use a small motorized power press, which is 25% more efficient. And now you can, your dried seed costs are $2 a gallon, all right? Well, that's still too high priced. And that's why the value of the seed cake is so important. You have to have a market for that seed cake to lower the price of the oil. In Africa, again, and in Asia, seed cake sells for around 3 cents a pound, so that reduces the dried seed cost to about $1.25 a gallon. And that's sufficiently low that you can you can do all the other processing steps and provide a good return along the entire value chain. So in summary, ethanol, biodiesel, and plant oil fuels all have a role to play in Haiti's future energy portfolio. But I'm saying we should start with plant oil-based fuels, and I'm saying that because there's a need to build up the supply of plant oil. There's a need to establish the appropriate local scale seed oil processing centers. And these centers would not be just used for jatropha, but for other plants and like castor and avocado, peanut. And there's a need to establish value-added markets for the seed cake. As a fertilizer, as a boiler feed, as a charcoal fuel substitute, or if you, through genetic modification or using the proper genetic variety of jatropha, you can have a seed cake that's not toxic, and then it could be an animal feed. Okay, and from that solid agricultural base, a successful biodiesel industry could be established. Now we're going to talk a bit about policy options. What can the government do to promote biofuels? And these are sort of examples that are used in the United States and EU and Brazil is, tax exemptions for biofuels. Now, Haiti doesn't tax their fuels that significantly. 6% is the tax on diesel fuel. In the United States, it's 18%. In Germany, it's 50%. So, but it's still 6%. Still would be a help in terms of making biofuel more cost competitive. The former Minister of Environment suggested putting tax penalties on petroleum fuels. So that way the government gets more money for fuel use, encourages conservation, and also puts a premium making biodiesel or pure plant oil fuels less expensive. Requiring biofuel blends for electric power production, again, would create a market at the 1 or 2% level for electric power production or transportation fuels. And then tax policy that would promote diesel fuel use over gasoline use because diesels are 20 to 30% more efficient. Recommendations, basically the USAID should work with the existing Haitian stakeholders to define an action plan for biofuels. Again, the Haitian stakeholders are incredibly enthusiastic about this idea. And the key is to walk alongside them and enable them to succeed. I think pure plant oil fuel should be encouraged first before biodiesel and ethanol production. Plant oil fuel markets that directly benefit small farmers should be promoted, and that requires a lot of support. We need an agricultural risk assessment on jatropha, and actually looking at the other potential oil-bearing plants that have potential. A plant breeding and genetic assessment, providing the farmer with the right seeds and the capacity for those seeds to have more value. If the seeds have higher oil content, if the seeds are easier to pick, if the meal cake Is it animal feed? Is it not toxic? All those things provide a better return to the farmer. The small-scale seed harvesting and processing technologies. That's really key to this. One of the key technologies to making this technically successful, making sure that the local community has the right technology to process the seeds. A market campaign focused on the sale of plant oil fuels to the local electric power utilities, seed cake market development, promotion of local investment in biofuels. After the initial market development, I think this type of market at the village level will evolve on itself, but it's still, USAID could look at helping these new markets using the oils for mill grinding and seed processing operations, irrigation, lighting, cooking, soap production. Provide the training at all levels of plant oil production. I mean, even things like how do you store the seeds, how do you store the oil so it doesn't spoil are very important. And so training and access to the appropriate technology to assure success. And then to encourage the newly elected Haitian government to consider tax policies that promote biofuels. And if they don't want to promote biofuels, not to hinder biofuels. Thank you for your kind attention.
Now, we're going to have a coffee break, a brief coffee break now. Everyone does seem to be doing a good job of staying awake, but we want to break up the session a little bit because we have two discussants with special expertise, one in economics and forestry, and another one in biology and plant genetics. And we would like to ask them to respond with comments that they might have from their particular expertise on this session, on anything that has been presented today, but particularly in this session. We will take a brief break and then and have them make their brief comments before we open it up for discussion. The other thing I wanted to mention was that Yves Gaussin was scheduled to be a part of this session, was unable to come at the last minute, and so Mike Bannister has covered for him on the issue of generating income in watersheds, so he will not be presenting this afternoon. Let us take that, make it a brief break, and we'll give you a call after a bit and finish this session with the discussants and then our debate, our discussion.